Hi everyone, this is Ghazvinian. I'm going to present our work about design and fabrication of spatial structures with mycelium-based composites to you. This is MyCreate, the spatial branching structure that we fabricated with mycelium-based composites. Mycelium is the vegetative root of fungi which decomposes organic matter for absorption of nutrients. In this process, mycelium bonds the organic matter together. The incomplete decomposition results in a foam-like material, the mycelium-based composite. This composite is lightweight, biodegradable, and a structural material that works best under compression. To find out the proper ways of making use of this material for compressive structures, we went through a recursive method including the material exploration, geometry optimization, and fabrication of various prototypes. To enable the final outcome of our project, the MyCreate Pavilion, we went through these different stages. We started by material cultivation. Cultivation of mycelium-based composites includes different stages and parameters. As many of these parameters are controllable, the material properties can be tweaked and composites with graded properties can be obtained. For MyCreate, we used waste sawdust and straw as our substrate, inoculated with oyster mushroom spawns. After the cultivation, we tested the material. We cultivated 35 different mixtures of material and tested them for mechanical behavior, especially compressive strength. We decided to use these 4 grades of material for the pavilion. Then, we explored developing a computational form finding framework for structures in which all components work under compression. We took into consideration the outcome of material exploration stage. We developed a Voronoi-based approximation of the medial axis method to generate forms that can find the horizontal and vertical equilibrium with a compressive-only manner. We discretized the form into smaller components for making it possible to be used with the mycelium-based composites. Here, different forms generated by our method can be seen from simple to more complex compression-only networks. We then started making prototypes to explore ways to materialize these forms with mycelium-based composites. We developed our method to fabricate a 3-dimensional structure with 2-dimensional cut materials that are totally recyclable. We used wood and paper to make the formworks. We experimented with different sizes, details, and connections for the elements and various cultivation and formwork filling protocols for the materials to avoid contamination. In order to make the material workable, we implemented a series of tests with different bio-based additives such as psyllium husk and guar. We made 4 different prototypes before the final outcome. Here you can see one of the smaller scale prototypes that we fabricated with 13 components. With the information from our experiments and prototyping, we started designing the final form of our entry, the MyCreate Pavilion. The boundary conditions and the properties of the material that we used resulted in a spatial form of 2.5 by 2.5 by 1.7 meters. We discretized our final form into 64 elements. The method that we developed contains an inner skeleton made of light birch wood. As mentioned before, we used 4 different grades of the material that we cultivated for different parts of the structure. You can see these different composites in this diagram. The stronger components are closer to the base of the structure, and the lighter components are used in the upper parts. To avoid the negative effect of capillary water on the structure, we used aluminum for the 7 base elements. In a closer look, you can see the details of each component in this diagram. Each component has 3 major parts: the outer shell, the end plates, and the guide straps. They also has the plate to shell and plate to plate connectors. At the end, we fabricated the MyCreate Pavilion. We started by cultivating the materials in bags for about 2 weeks. We cultivated 52 bags, including around 120 kilograms of fresh mycelium paste. We cut the formworks with laser and water jet and then filled them with mycelium paste and let them grow for more 7 to 10 days. Finally, we unwrapped the formworks after they got shaped and let them dry for 2 days in front of a fan. This is how the components look like after being dried. The compression-only structures are self-standing only after being assembled completely. Before assembling all the components, we had to use temporary scaffolds for making it stable. Here is an instance of the assembly process. We assembled the microcrete pavilion in about 6 hours and removed all the scaffolding to make it self-standing. The final pavilion was about 80 kilograms and stood for about half an hour before collapsing. We learned a lot about the spatial structures with mycelium-based composites. Although the overall framework works well and the structure worked in compression-only manner, some minor deficiencies, like the mold issue caused by the wood and the lack of proper drying protocols, caused an early collapse. We appreciate all the efforts of our hard-working team and look forward to resolve the problems and fabricate the next structure with this material. Thank you for your time and attention.